Okay, I wanted to do a quick little video here on the use of Pythagoras' theorem in more dimensions than we've been using it in 3 dimensions. So if we consider the following shape, which is, it's a 3D shape, we can have like this box, for example. You can see that it's drawn in 3 dimensions. We've got some dotted lines to represent the fact that you would not be able to normally see through. We have a distance that we are asked to find. We are being asked here to find the distance from point A, which is down here, all the way up to point G. So, in order to do this, we're going to need to actually multi-step. This will be a multi-step problem. We're going to need to find another distance to help us along the way. In particular, we're going to need to find this distance from A across the bottom over to C. The reason why this is, and I'll draw a little line on here for you, is that this distance from A to C would then give us the base of a triangle that exists inside that 3-dimensional shape. Okay, so that's really what we need. We need that distance from A to C. So let's do that. So for the length A to C, we start off with our theorem, our Pythagoras' theorem, the equation for it. So a squared is plus b squared is equal to c squared. Now, for this instance, I'm going to refer to this as x because I don't know that distance. So let me just move this up and we will substitute in. So we'll have 5 squared plus 7 squared will be equal to my unknown squared. I can do that. I can get my 25, which is 5 squared, and my 7 squared is 49. I can add them together. I'll get 74, which is equal to x squared. And then I need to find just x by itself. So I will find the square root of both sides. When I bring this square root down, on the right-hand side and get rid of the square root of x squared, I'm not actually going to do anything to the left-hand side. I'm going to leave my answer as the square root of 74. And there's a reason for that I'll tell you very soon. Okay, so let's move this right up. Let's go back to the drawing. And in fact, I've reprinted it down here so that I don't have to move my screen back up. We have a distance now for AC, for that length AC. That now gives us the ability to find the length of AG, which is the next part of this. So we'll find the length AG, again, down here, all the way up to here. Remember that dark red triangle that we have now got 2 lengths for that. So we'll write our formula first. A squared plus b squared equals c squared, and we'll substitute in the things that we have. It just crashed. I got it back up. So we'll continue on. Now you'll note that I have a length that is the square root of 74, which is an odd sort of number, but the reason why I've done it is when I write it as a substituting into the equation that I've got, it's actually kind of nifty. The square root of 74, when I square it, the answer will just become 74. Now, that means that my calculation that I did in the first instance, if I had rounded that off, I would not get as neat a number here. Okay, so it's important to sometimes keep things in the square root form so that you can use them and it be more accurate. Okay, so I can do this. I can now do my 74 plus 9. So 83 will be my number there, which is equal to c squared. Once again, I will be able to find the square root of both sides to get my answer of just c. And here I have my square root of 83 is equal to c. And so 9.11 centimeters is approximately equal to c. Now I'm okay with an approximation as the final answer here because I was asked the distance, and even though root 83 is a number that will tell you a distance, it's not an easily understandable number in terms of a measurement. We're not quite finished yet because this was a worded question at the very beginning. It said, what is the distance from A to G? So we have to refer back to that and write a written answer. We would say, therefore, the distance from A to G is 9.11 centimeters. Okay, so that's using Pythagoras in 3 dimensions. Now, as soon as you are dealing with a third dimension, it's still easy enough because it's still just triangles. Okay, so look for the triangles in things, and that you can use the sort of knowledge that you already have.